So here's a problem that involves the ideal gas law, problem 532. We have the number of moles of carbon monoxide, CO, and that's the number of moles N, 6.9 moles of which are present in a container that occupies 30.4 liters of volume. We're going to call that V. And we have a pressure that we are being asked to find if the temperature of the container is 62 degrees C. And so we got P, we have V, we'll always have R, which is the gas constant, and then we have N. So PV equals nRT is what we will use to solve this problem. This is your classical ideal gas law equation. We'll solve for P, and that's going to be nRT over V. So let's go ahead and do that. We got our V, we got our temperature T. Don't forget to convert that to Kelvin. So let's solve for P here. P is equal to nRT over V. Our N here is 6.9 moles. Make sure you always put your units here. R is something I will give you, so do not worry about that. And then, but one thing you should do is make sure you have the units intact. It's 0.021 liters atmosphere over a mole Kelvin. Temperature T is not 62 degrees. It's going to be 62 degrees plus 273 because remember, Kelvin, Kelvin, Kelvin for gas laws. So let's do really quickly. 273 plus 63 is going to be 335 Kelvin. So our T is 335 Kelvin. Okay, so I got my R, I got my temperature T, I got my N, and then my volume. My volume is 30.4 liters if you look at the problem. Okay, R is 30.4 liters. So one thing I like to tell people to do is cancel out their units. Liters will cancel out with the liters. The Kelvin will cancel out with the Kelvin. The moles will cancel out with the moles. So you're going to do on your calculator 6.9 times 0.0821 times 335. And we're going to divide that by 30.4. And this is going to be 6.24 atmospheres. Make sure we got our units correct. Yeah, it's going to be atmospheres. So let's do two significant figures for this guy. So we'll call it 6.2 atmospheres. This is a practical application of the ideal gas law.